So we're going to pivot to our final speaker here in a moment, and one of the benefits of our kind of post-COVID hybrid approach is we can have not only remote participants in the audience, but when necessary, remote speakers. And so that is the case today for Ian Farquhar. Ian is with Gigamon, where he's the field CTO. He's going to talk about operationalizing zero trust. And so we have this part ready to go and pre-recorded. Ian is plugged in remotely for the Q&A at the end, and so I will hand this over to him.
Hello, my name's Ian Farquhar, and I'm field CTO for Gigamon. My focus at Gigamon is on zero trust, and today I want to talk to you about a different approach to looking at how we're all going to implement zero trust architecture. So let's start with a very obvious statement. I'm going to call it an axiom. Failure at scale is just not an option for any of us. We need to make this work. We need to make this efficient. And anything we can do to help on that path is something we all should be thinking about. Now, many of you will know the next part, but it's worthwhile just spending a minute talking about how we got here and some of the root standards that we're all working to. Obviously, most of us are implementing it because of Executive Order 14028, which requires zero trust architecture. It was a mandate to implement it. We have NIST's very, very good NIST SP 800-207, the standard definitional document building on top of John Kindervarg's 2010 work on zero trust to define what a zero trust architecture is. Even moving beyond US government standards, just looking at evolving standards for zero trust around the world, this document is the cornerstone of everything. It is a very, very impressive document and worth reading. But then we split into two paths. We split in terms of US government implementations into the DoD approach, the DoD Zero Trust Reference Architecture version 2, an extremely well-developed document that is moving forward at pace, ton of associated documents around controls and policy and strategy, very much leading the way in implementations of zero trust. But for the civilian agencies, and definitely developing behind it, is the CISA Zero Trust Reference Model and the associated documents like NIM 2201, NIM 2209, that civilian agencies are building their zero trust approaches to. So we have the root definition document and the two paths that various people in the audience listening to this will be pursuing. So I want to say a second very obvious thing. Complexity is the enemy of security, and that really is a theme for today. We need to do something complex, and we need to do it securely. And to do that, we need to try and drive complexity out of what we're doing. But that's going to be rather hard, because when we look at typical government agencies, they are complex beasts. Most people look at this through the lens of the network, on-prem, private cloud, public cloud, and that's a totally valid way to look at it. But consider even on-prem, there are so many different variants of that. Looking at cloud, you've got multiple cloud service providers, the big four. Private cloud, you've got multiple hypervisors. Look at it in another way. You have brownfields versus greenfields approaches, and then you get things like SaaS. And finally, at the far end, we even have the edge cases, legacy compute. Who keeps a mainframe around because it's fun? No one does that. They're very expensive. We keep a mainframe around because it's full of sensitive data that is mission critical to our organizations. Therefore, that legacy compute is going to have to be part of our zero trust architecture. BYOD in civilian agencies. If you're in the military, your ability to operate in a coalition with various partners or have mobile platforms will be a complexity when you come to implementing the DoD RA. I'm not trying to depress people by saying this, but saying we've got to do this. And there's one thing I do want to point out, and that is we won't ever get to a nice, pure situation. Everything we do, no matter which agency you are, we will end up with hybrid approaches. We will have applications spanning all of these environments. We will have applications partly on-prem, partly in the cloud, partly in multi-cloud. Hybridization, hybrid approaches is going to be inevitable. And unless our ZTA deals with hybrid environments effectively and elegantly, they're going to fail. Core concept of zero trust is the idea of implicit trust, and that is trusting something without a rational reason for doing so. This is included in the standard, page 1, the introduction. No implicit trust, constant analysis and evaluation of risk and business function, and then enacting protections to mitigate this risk. That is the core requirement, the idea we trust absolutely nothing without proof that it is actually trustworthy. I want to pause and think about, if we're going to do that, something we need to have no implicit trust in is the controls that implement zero trust. And that might sound a bit recursive to you, but consider for a moment when you're deploying critical business services. In terms of availability, you always deploy redundancy because you understand that systems can fail. Why would you think that zero trust control will never fail, particularly in the face of a threat actor who could force it to fail? We need to look at the controls that implement zero trust, not as perfectly reliable, but as things subject to failure. Therefore, we need to drive implicit trust out of our zero trust architecture. We need to look at all of the controls that form our zero trust architecture and decide why we trust them and make sure that we are not implicitly trusting them. It's in the standard. Now, when we're talking about this, what we're really talking about is the ability to see threats. There are 3 different approaches to visibility that are common in most organizations. The first is logs, traditional logs. They come from applications or operating systems or services. There are the agents we install to provide telemetry. And there is monitoring something from the network, the 3 approaches. Some people call this a SOC triad. Nonetheless, the 3 different approaches that typically define visibility of potential risk. These really fall into 2 categories. The first is the inside, things that come from inside what we're trying to measure. So if I'm running an EDR agent, it comes from inside the workload that I'm monitoring. Same for logging and apps and so forth. If I'm looking at the network, that comes from outside. It's a tap or a span port, or maybe traffic logging, traffic monitoring up in a cloud service provider. These are the 2 approaches. The first is called observability, MELT, and the second is deep observability, monitoring something from the network. All of these approaches are absolutely valid. But there's one thing that differentiates observability from deep observability. We are trying to judge whether something is trustworthy. We are trying to detect the presence of threats. If I have a threat actor on a workload, on a system who has violated some SaaS service, one of the first things they're going to do, as we saw with SolarWinds, is turn off logging, disable EDR agents. Anything that comes from inside the blast radius of an attacker is fundamentally mutable. Once they have taken control of that system, that telemetry is not necessarily trustworthy. Why would you trust it as part of your ZTA? However, the deep observability, the visibility from the network, that's outside their blast radius. In fact, the more they do to evade it, the more network traffic they actually generate in their activities, the more they'll actually be seen. This is a very interesting approach because a lot of approaches to zero trust have been very, very focused on the hosts. What I'm proposing here is that we look not only at the observability, but the deep observability. We make sure that visibility of our network is a core requirement of ZTA. And you'd think, right, that would actually be in the standard. So why isn't it? It actually is. NIST SP 800-207 says it very, very quickly. It's a section called Network Requirements to support ZTA. The enterprise can observe network traffic. The enterprise filters out metadata about the connection to dynamically update policies and inform the policy engine as it evaluates access requests. deep observability is a requirement of zero trust. Now, at this point, I want to talk about why this is so interesting, because a lot of people who do incident response and so forth, they very much focus on hosts and on workloads and on the cloud infrastructure, and the network is something that's worried about by other people. But the network has some fascinating properties that are very, very useful and very, very relevant to this discussion today. The first one is to observe that all the environments we deal with, cloud, the two types of cloud, public and private, and on-prem, a packet is a packet. While it's traveling over different medium, we can process it in the same way. Therefore, it collapses the complexity, whereas we're dealing with multiple different logging types and different types of agents coming from all of these environments. The telemetry that can be generated by just generating network metadata is exactly the same across these environments. It makes the complexity disappear. Furthermore, the way we report it, the processing of metadata into a telemetry stream, doesn't require normalization. We can treat them in exactly the same way. That SMTP transaction up in the cloud versus on-premise looks exactly the same. I don't need to normalize the data. Now, as so much of what we're talking about in ZTA is based around AI and ML analysis for generating anomalies, the fact that it all comes in the same taxonomy without normalization makes that so much more powerful. In fact, I'm going to say at the moment that if we do it this way, if we use deep observability and report all network transactions using the same taxonomy without normalization, our AI and ML will be much, much more effective. Network activity is collected outside of the blast radius of the attacker. It's not mutable. They can't just turn it off. They can't spoof it. It's very, very hard for them to evade detection if they're being monitored from the network. And the equipment that is needed to do this already exists in many agencies. In fact, of the 152 controls on the DoD Zero Trust reference architecture, just under 50% of them would benefit from having access to the network provided by deep observability. This crushes complexity, and complexity is the enemy of security. Now, I'm going to make a key point here. Many people will be probably hearing me say, do deep observability, don't do logging, don't do agents. And no, I'm not saying that. The question is not which one to do. The answer is to do all of them. The question is to do which one in priority, and that's a judgment call you all can make based on your environments. Really, what I'm saying today to you is do defense in depth. It's not like this is a security principle we haven't understood for 40 years, and it applies to ZTA just as much. In fact, I would argue that the prohibition on doing no implicit trust is just another way of saying defense in depth. We need to assume that controls will fail, so we need to have controls cross-checking each other. This is the way to do it. Finally, in closing, I want to talk about just a proof point. The Department of Defense did one of the very early pilots of ZTA. They initially built it using microsegmentation as their primary network control, assuming that segmentation would prevent lateral movement of an attacker from various workloads running in their environment. They took a red team in and it didn't. The red team was able to successfully move across this environment. Unfortunately, that caused it to fail in its design goals. GigaVUE was brought in. We added the ability to see all network deep observability, essentially, and the red team was brought in again. They were spotted and defeated. Deep observability made it successful, and that is a key point that I would like to make to you. You really should be looking at this for your ZTA infrastructure. So my call to action, I'm absolutely saying do logging, do agents, no argument there. But if it runs only on them, you're dealing with malleable telemetry and you will be vulnerable. Instead, add deep observability. It's a core requirement of any successful ZTA. Deep observability will give you a quick deployment across multiple environments using equipment that's already installed in multiple agencies. potentially including the one that you work for. Deep observability also provides telemetry, which is not malleable and requires no normalization. Huge benefit in integrating it into a policy engine. It will make hybrid environments very visible and accelerate AI and ML analytics very, very straightforwardly. You can get early wins. And because you can use cross-checking of the integrity of your telemetry, logs, checking agents, checking deep observability, all checking each other, you have no implicit trust. You are meeting zero trust requirements for driving implicit trust out of your environment. So even the controls you are using can be checked and validated. And with that, I will say thank you. I really appreciate your time today, and I will now open up for some questions.